Welcome back, chemistry fans. Today, what we're going to do is the Unit 8 exam free response questions. So, writing something down there. Sorry, here we go. Let's jump into it. Let me give you the versions of the questions that you saw. Let me blow them up so you can actually see them a little bit. So this first question here is asking about bond energy in a reaction. Okay, oh, I'm sorry, this is asking about lattice energy. And so what we have to do here is create barium chloride. Now, as it goes with this, all you got to do is add up all these values together according to this Born-Haber process. But there's one of them in here that's going to have a mistake. And the mistake happens to be right here because there's this incongruency. There's discordance. They don't equal one another because this only has one chlorine. And whenever I take these chlorines and add electrons to them, I have to do it to both of the chlorines. So that means this value needs to be multiplied by 2. Everything else is just the same. So what we're going to do is we're going to add all these values together. So that's negative 2056 plus 503 plus 965 minus 348 times 2 plus 239 plus 178. Okay, and that equals up to be a negative 867. That's all you had to do on this question. Fairly simple task. All right, let's jump then to question number 15. All right, now this one was a lot of steps, and so you could easily get lost on it. And there's some examples in here that some of you took as answers. For whatever reason, you thought that I would give you the answer in the question. That's silly, but you just didn't quite read the question. We are looking at OF2. We are trying to figure out what this Lewis structure looks like, and then we're drawing it three-dimensionally. So let's go down here. Let's find some space. Well, let's just find some space right up here. So this is not an expanded octet. So we are going to do want minus have. So want, there are 3 atoms. They each want 8. That is a total of 24. The haves, there is 1 oxygen, and there are 2 of the halogens, which are the fluorines. So that's a total of 20, meaning there's a difference of 4 in between here. The first element goes in the middle. Fluorines go on the side. Because there's 4 divided by 2 means there's only 2 bonds. Now, what some of you left off are these extra electrons that are on this. So this is my Lewis structure. Now, what does this look like three-dimensionally is something more like this, because it's molecular geometry based on that one, because there is repulsion of these electrons, forcing it going down, means that it is the bent molecule shape. If you looked it up during the test, your online answers are not going to be correct. Label all bond angles. So when we have a bent molecule, what we have, yes, is a tetrahedral shape, but it only has 3 atoms in it. So the bond angle between these does still stay at the tetrahedral angle of about 109. If you looked it up, it would have given you a specific value. We have not studied that, so that is not what I was hoping for. Label the location of all the dipole moments. Okay, so now we could have done this in 2 different ways, and I would have been flexible in my answer, but wanting it to look something along these lines. So if we had our molecule looking like this, there's not a whole lot of difference in their shape. So what we should have seen is that the electrons would be pushed downward down here, because there seems to be more electrons down in this region of it, because there's more atoms down here. Now, let's go and let's look at the electronegativity chart here. We have F and we have O. The difference is 4.0 minus 3.5. That is 0.5. That is just on that cusp of being something that is significant. So we would want that answer to be, let's see, it's small enough that we would want it to be nonpolar in here. That difference is small enough. State the shape polarity. Based on the shape, all bent molecules are polar. state the size difference. Well, they're the same on the same chart. So there is nonpolar according to size because they are very close to one another. And then let's see, hybridization. Okay, so because of this hybridization, there's only single bonds in this one, but it has 1, 2, and then these extra pairs actually count towards it. So I have 4 locations, 4 ligands where there could be potential bonds. That's S, P, 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 that is SP3 is the hybridization. And then the bond order. We don't have any resonance structures here. So there's only 2 locations for bonds, and they both have single bonds. So that's a total of 2. So the bond order is in fact a 1. Okay, so that takes care of this question, everything to do with how we should figure out the way that we represent bonding within these atoms. All right, within these molecules. So now we've got turn our attention to a bond energy table, and we've got this shown molecule here. And what we want to try and do is get of bonds. So I've got 2 of the NHs. So I look for NH on here somewhere, and it's 391. So that's 391 times 2. I have 1 NC bond. So that is right here. That is 305. And then I have a C double bonded to an O. That is 799. And then I have a C single bonded to an O. That's 358. And then I have 1 OH, and that's 467. All I got to do is add all that together, and that will come up with what my bond energy is associated with this molecule. Plus 391, plus 391, plus 305, plus 799, plus 358. You add all that together, and you get 2711 as your answer. Okay. Next is the last question in the free response. It's number 17. And in this one, we are doing a formal charge. Okay, so what we're going to do is we're going to go and use the formula. The formula is valence electrons minus number of bonds. So for nitrogen, it's 5 minus number of bonds, which is 3, minus the number of free electrons. Minus electrons. And so this ends up being a 0. Now we'll do it for carbon. Carbon has 6 valence electrons. It has 4 bonds, and it has 0 free electrons. That's a -2. And then the oxygen, I'm sorry, 4 minus 4. Shoot. 4 minus 4 gives us 0. And then the carbon, the oxygen is 6 minus a single bond minus 6. That equals a -1 for the electrons. All right, well, that's coincidental because that's what it should be, as a -1. So that's where the charge. All right, let's do the same thing now for the carbon next to it. So I put the carbon on the left side, and it has 4 minus 3 bonds minus 2. That's a -1. The nitrogen is 5 minus 4. That is a +1. And then the oxygen, same charge as what it had before, is a -1. All right, now let's do carbon. 4 minus 2 bonds minus 4, that's equal to a -2. The oxygen in the middle is 6 minus 4, that's a +2. And then the nitrogen is a 5 minus 2 minus 4, and that is equal to a -1. All right, you always go with the most likely structure is the one with the most zeros, or the values that are the closest to 0. And so that is the first structure over here. And that is everything that I need for you to show me, to prove to me that you understand your formal charges. This will conclude our first portion of the test dealing with the free response questions. So thank you very much. I will talk with you again soon. Bye-bye.